So chapter 9, we've got a quote from Isaac Asimov. Beginning students of chemistry often think of the science as a mere collection of disconnected data to be memorized by brute force. Not at all. Just look at it properly and everything hangs together and makes sense. And I would encourage you to consider that. There are some subjects that require a lot of memorization. I've never taken anatomy, but I imagine that to be successful in anatomy, you have to memorize a lot of things, right? Bones, muscles, where they are, what they do, etc. Just lots and lots of memorization, right? And there is memorization involved in chemistry, but there's also a lot of patterns and understanding how things work. And that's one of the things I like about math, is you learn how math works, and then you can do lots and lots of different things. You know, you learn about addition, and you can do all kinds of problems, not just one. And so we learn to understand chemistry, and then we can do a lot of different things. It's difficult the first or second time around in general chemistry to understand all the stuff going on behind the scenes, but I would encourage you to try to look at the bigger picture and not just at all the little details, because the big picture is actually quite beautiful. So this chapter is about periodic properties of the elements. I skipped the first section. It's very interesting, but I'm short on time in lecture, and so you can read about that, but I'm not testing you on that. So this is the second section of chapter 9. So Dmitri Mendeleev is often given credit for the modern periodic table, and the book discusses some of the other people that had similar contributions. He is not the only one who made progress on this. But he ordered the elements by atomic mass and saw a repeating pattern of properties, and this led to the periodic law. When the elements are arranged in order of increasing atomic mass, certain properties recur periodically. So he used the patterns that he observed to predict the properties of undiscovered elements. And there were some places where the atomic mass order didn't fit with the properties, and so he chose the properties over the mass. An example of this is the elements tellurium and iodine. If we look at these on the periodic table, tellurium comes before iodine, and yet its mass is larger. At this time, it was not known that the ordering property is the number of protons. The number of protons, for the most part, lines up with the atomic mass, but there are a couple of places where it does not. So he followed the properties. So here are his predictions for two elements that were discovered later and their actual properties, and he was very accurate in his predictions. He predicted the atomic mass for both germanium and gallium. He predicted their densities. The formulas of oxides and chlorides is pretty impressive. So Mendeleev's periodic law allows us to predict what the properties of an element are. That's how he predicted the properties of these undiscovered elements. But it doesn't explain why. Quantum mechanics is the theory that explains why. So we have the periodic trends, we know what they are, but then knowing why allows us to predict even more of what happens. So it's a benefit.